Testing. I should be live as people are joining in. If you want to say hello in the chat, that would be great. I'll type hello in there as well. And it's always fun to hear where people are watching from. So if you want to put in where you're streaming from, please do that as well. And then also, if you want to share anything else about what you're building, maybe why you're interested in learning more about building ML pipelines or large language models, let me know in the chat. It's really fun for me to hear. Also, I think for other people tuning in too, also kind of fun to see what other type of people are here at the workshop. And we're a minute early, so we're going to wait a couple minutes probably before we really get going into the presentation and then code. So I'm going to start with some slides, but then we're going to go into code and actually implement a pipeline to fine-tune our Bert model, which is a type of large language model. And then this also can really be used, like all the stuff we're going to use today, can be used in more complex workflows or with more complex models. So Bert model, if you haven't heard of it before, it was kind of one of the kind of, I want to say maybe earlier transformers, but it's one of the transformers that really started being used a lot in production and kind of brought transformers to the forefront of what people were thinking about for a large language, or for NLP, kind of before GPT models came out. And we're going to train one today to look at a lot of unstructured inputs, so in this case text, and then do classification on it. But again, if you want to fine tune a large language model for other tasks, this can be relevant to it, and you can bring in bigger models than the Bert model that we're going to use today. But we'll be able to go fine tune this, get results kind of all within the hour of the workshop, which is great. But if you need bigger GPUs for bigger models, those are also going to be available in the platform that we're going to use today. And again, while people are joining in, I'll just quickly show kind of maybe a quick preview of what we're going to build. Actually, before that, I will share links. So as you're joining, hopefully you should see these. They should also be in the description below as well. So also if you're coming back and watching the recording, and you want to follow along, which I hope many of you do, the links are in the description below. Mainly, you'll just need to sign up for a Union account. It's free to sign up. There's no card required. You get $30 of cloud credit that we're going to use just a tiny fraction of today. And then you'll want to go to this GitHub repo to follow along. That'll look like this. And we're going to run all of our code in Google Colab. So if you want to, you can hit this open in Colab button. And I'll go over this again when we get to the code part. But I know that some people like to kind of go ahead and poke around at stuff before. I know I like to do that sometimes. And then also, if you have any questions outside of this workshop, so during the workshop, ask them in the chat here, and I will see them. But outside of this, like if you're coming back and watching the recording, or if you have questions later, join the Slack channel. It's a pretty large community there of over 4,000 people now. If you have questions about just MLOps, but also doing something in Union or Flyte, which again, we'll talk more about what those are here in a little bit. And if I sound a little extra weird, I think I'm getting over a little cold from the weekend. So apologize for that. All right, so I'm going to quickly show kind of what we're going to build, and then I'll go through the slides, and then we'll go into the code and get started. So we're going to build a workflow or a pipeline, really, of training a large language model. What we're going to do first is we want to download a data set. We also want to download the model. Both of these are going to be from Hugging Face, which is a popular platform to store models and data sets in, but they also maintain some of the popular transformers libraries, namely the one called Transformers, which contains a lot of the like Llama 2, et cetera, that you might want to fine tune, and the Bert model that we're going to use today. Then we're going to train that model on some GPU resources. We also want to visualize our data. I always like having a step like this, whether it's baked into the downloading dataset part or a pre-processing step where I can actually see the data being used. So in this case, we're going to train our model on a IMDb review dataset. So it's going to take this unstructured text of this is a positive review, this is a negative review, and then we're going to be able to classify those. But I like to log my data and see like an example, in this case, what a positive review looks like, what a negative one looks like. And then this chart might be overkill because in the IMDb dataset, it's at even distribution, but I like to see my distribution of different classes, etc. So I can log all this in a task here. So each one of these nodes is a task that the collection of tasks makes up a workflow or the pipeline that we're going to build today. And then we'll evaluate our model, and then we'll also predict sentiment. So we'll be able to pass in new text, and we'll do this from the UI here, but also from a Python API. And then you could use this kind of as a model hosted for batch inference. So if you actually did want to pass multiple things, this is actually an appropriate way to host the model. And then we'll see what our model says. So again, we'll do all this. This is a kind of a, maybe a simplified, maybe not, depending on the type of problems you're working on, a whole kind of pipeline. And it has all the state-of-the-art things built in, like versioning, caching, and stuff that we'll talk more about here as we go through. So again, if you want to follow along, I posted links in the chat, but also there in the description as well. So I'm going to go through the slides, and I saw a whole bunch more people join. So definitely say hello in the chat and maybe put where you're watching from, which is always fun to hear. So again, we're going to fine tune a Bert model, but you kind of saw we're going to build a whole pipeline around it, not just fine tune a model. Just a tiny bit about me. My name is Sage Elliott. I work at Union. We are a platform for AI workflows and inference, and I live in Seattle. That's again, put in the chat, where are you watching from? I also run an AI book club where we've been reading a new book every month. This month we're reading the Kaggle book, and then next month we're reading Building Transformers from Scratch, which I think will be really exciting if you're interested in LLMs, which I'm guessing a lot of people here are. And then previously I've done a lot of work in computer vision, ML monitoring and evaluation, also a fair amount of hardware IoT, and then MLOps, and kind of combining all those together sometimes, like putting a computer vision model into like a literal field, like a field you would harvest, and monitoring crops that way. Oh, and connect with me on LinkedIn. If you have questions, you can reach out there. But also, again, I'll share the Slack link. This is going to be a good place to join if you have questions later outside of the workshop. I see you, Rich is here. Hey, Rich and Rahul. Welcome, welcome. Thanks for posting the chat. And again, it's an opportunity for you to kind of post where you're watching from. What are you working on? Are you working on other tools in this space? Are you building something interesting with large language models or other type of machine learning models? And then, yeah, why you're interested in ML pipelines. It's always fun to hear a little bit about what you're working on. Again, overview of this workshop. We're going to build that whole model workflow. If you were here just a few minutes ago, I kind of showed what that looks like. We're going to create a container image as well, which is usually an important part of creating a reproducible workflow. You want to create a container that's a reproducible environment that you can kind of share between different tasks. And every time you run the workflow, you're going to get the same results. And then we're going to download a data set, download model weights, process and visualize that data. And then we're going to fine tune the Bert model. We're going to run evaluation on it. And then we're going to, this is actually an optional step. We're going to save a model to the Hugging Face hub. And then also we'll see how to predict sentiment from that model that we just trained after we evaluated it. So again, I'm going to go through some high-level concept overviews just to kind of make sure everyone's on the same page. And then we're going to go into the code. And again, like if you're super new to machine learning or something like that, it's okay if this feels a little fast-paced, but you'll actually be able to run all the code, even if you've never trained a machine learning model before or fine-tuned an LLM. Don't worry. I'll be walking through the code, and it's just okay if you're like, oh, I haven't seen that before. I don't quite know what it's doing. You can always come back to it, and you'll learn a lot by sticking through it. So just kind of a quick recap of like what MLOps or LLMOps is and building ML pipelines. So MLOps is really the set of best practices where you're bringing these tools together that aim to deploy, monitor, and maintain machine learning models in production. And I like to kind of bring in the terms like reliably and efficiently. This is a very simplified ML pipeline, but you're probably always going to have some form of these steps and then probably way more. So you'd have collecting data, training a model, evaluating that model, and then you're going to ship that model to production in some way. Again, this really varies depending on what you're building. Like I had mentioned, I put models in edge devices and farms, but it could also be hosted in the cloud somewhere. This could be on your computer. There's just different variations of where you want to put that model. Once that model's in production, typically you're going to want to monitor it in some way. So has anyone ever put a model in production and then seen something interesting happen with it? Typically, at least, you're going to want to monitor the data going into the model. and the predictions coming out of the model. That'll allow you to detect like if your model is behaving interesting and differently than it has in the past, as well as did the data drift or change. So it's pretty common that the data going into your model once it's deployed is going to shift from the training data that was on. And you want to be able to catch that. And then hopefully most of the time you're probably collecting some form of that data in production, capturing it and then maybe re-annotating it and then training your model. So this really becomes, people often call this like the data flywheel, MLOps lifecycle. You're really doing kind of all these steps over and over again to kind of keep a fresh model that's going to be performing well. And also, again, like I mentioned, this is a really simple one. You're usually going to have more steps like processing data, prompt management, especially with LLMs, vector databases. You're going to want to add in guardrails, and there's a lot to be done with like A/B testing and deployment. But again, this is just like kind of a bare minimum pipeline. And has anyone built a pipeline kind of like this before? Some people have only ever trained a model. Some people might have only worked on the data side. Also, often these like workflows or these sections might be broken into separate workflows. So like we're going to build kind of one whole one today, but you might have steps broken out. Like a data team, data engineering might run a workflow that collects the data and pre-processes the data and saves it. Then you might have a machine learning team that does like the training and evaluation. And you might even have a separate kind of ML team or software engineering team that ships the model out in production and monitors it. And then again, you kind of go back between those teams. So you want to be able to build a workflow where you can like share all the artifacts being generated on each step and be able to like go between all these often. Fortunately, there's so many great tools in the field that make all this way easier. And you will kind of want to build a workflow with these. So again, kind of all the steps we talked about here. There's great libraries for training, monitoring, deploying. I think I saw Rich was here from YLabs, I believe. YLogs is an open source library by them. And then YLabs is a platform where you can send data up and monitor it, which is pretty cool. I'm actually working on a integration example with that right now. And then, so workflows, kind of the core of the pipelines that we just kind of showed briefly what that pipeline might look like. When you're building these out, there's some things that you usually want to keep in mind, especially if you're building these kind of at scale, but really at any stage. Reproducibility, which is you're going to ensure the workflows can be consistently reproduced. And this also usually aids a lot in collaboration and transparency. So this might be kind of hard to see here is a little image I made that it's like you have this little simple workflow here and it's kind of repeating because you're going to run it multiple times usually before maybe a model actually goes into production. And every time you run it, it kind of has a state of all the compute that was used, the data types that were there, was it cached? And then you want to be able to kind of have versions of all these different artifacts they produce. So you can actually go back and look at those different versions and or hand off artifacts to other teams like I'd mentioned. Scalability. You want to be able to facilitate the scaling of your workflows to handle large data sets and complex models. I feel like this is maybe even just more important now with the really large data sets and large models going on everywhere right now in Gen AI. Versioning, like I mentioned, you've probably used things like GitHub before, but typically for your whole workflow, you want to have things like track the data, track the code, track the prompts for LLMs, potentially, if you're doing something like a RAG and you have prompt management between queries. And then model version. So really just kind of a snapshot of your whole workflow. You can go trace this back. Sometimes too, this is kind of required in certain fields if they need traceability to be able to kind of audit like how your model was made, like in some healthcare and finance areas, I believe. Improved efficiency. So you really want to allow your data scientists or ML engineers to focus on building, not necessarily managing infrastructure most of the time. Someone at a talk that I was at not too long ago said something that kind of stuck with me is like, he said, my ML engineer should be able to get a model out in production or at least like in the kind of experimentation phase without writing a Jira ticket, which I thought was interesting. So everyone's really trying to kind of figure out how to build these pipelines so that their engineers can kind of work faster. And then also cost efficiency is a huge thing here. You want to optimize your resource usage. You want to reduce the overall cost of developing and deploying your models, which can come with a cost to the actual resources. But also, I think improved efficiency really adds a lot to that as well. And just to kind of hammer a little bit on some of the big cost efficiencies that I see a lot of people implement and then really love is optimizing for local and cloud development. So some orchestration tools or workflow tools only allow you to kind of run them in the cloud that they're tied to. But a lot of us have really powerful laptops, like I'm running on a MacBook M2 right now. It can do a lot for like training models and processing data sets. And I want to build out my workflow and kind of debug it locally without having to kick off a cloud job, wait for containers to spin up, and then get logs and then debug it. It takes a lot more time. So I really like it. I really like this now where I build a pipeline locally before I usually kick off my more production grade kind of workflow with expensive GPUs, but also just the time it saves me on debugging and iterating is a lot. I'm leveraging caching in the pipeline. So caching capabilities can speed up the development by avoiding redundant computation. So here's like a little example of a workflow where we're getting a data set, we're processing that data, and then we're training a model. Again, this workflow could be broken up differently, actually, depending if you have data teams or whatever. But here I'm pulling in a data set, and instead of kind of rerunning this every single time I rerun the workflow, I'm going to cache the data set and process data here. So when I rerun the workflow, it's just going to read from cache. So those already download, already processed, stored in that task. And then it's really just rerunning this train task, even though I'm kicking off the whole workflow again. Task level resource and resource management and containerization. So we're going to see today when we build our workflow, every single task, like each thing here is a task, like get data set, process data, train model, etc. Each one of those is going to be in its own container. And in that container, you can specify the exact image you want, but also what saves a lot of cost often is specifying the exact resources you want, and then even going back and monitoring that and adjusting it down if needed. So for example, this is the get data task that we saw before. We only want 2 CPUs and 2 gigabytes of memory in this case. And then maybe our training task requires a GPU, like the one we will run today actually will. And we want to set a GPU to the resources and probably a higher memory. So it's not like it's not running this GPU in the whole workflow. It's only running it in that task. So before, maybe you had a monolithic workflow, you spin up a compute cluster, every single thing would run in that cluster. Get dataset could be a massive dataset where it actually could take a long time to download. You don't want to be wasting that GPU time when you're not using it. So really, you just spin it up, use it when you need it, and then spin it back down. Mitigating errors with type safety. So you might be familiar with some strongly typed languages. In Flyte and Union today, you'll see that like this is actually enforced, even though we're writing in Python here. And this just really reduces your debugging time between creating tasks and ensures like when it kind of does documentation too. Again, we'll see this in action code. Actually, I can pull up a task here. We're just saying annotating the exact type of data that we're expecting like a task to output, and you also annotate the data that a task accepts as an input. And so it's kind of a way of documenting your code as well, especially if you're like sharing between different teams, and reduces the debugging and data integrity. And then something we won't actually do today, but a huge cost saver that I see people utilize is using spot instances when it's available, and or sometimes batch processing. So you can connect to a spot instance in your data pipeline in AWS, where spot instance is basically like a cloud provider spins up compute, and then it's sitting around there. Instead of them just kind of getting rid of it and not making any money off of it, they'll sell it at a cost. So sometimes I think it's up by like 70%, maybe even more sometimes, but it's not always available. So you can set up a pipeline. Like if you're okay with it not running immediately, you can have it kind of wait and look for these spot instances when they come available and then run on there. All right, so today in our hands-on part, we're going to be using Union. And just as a caveat, we're going to use something called serverless, which you don't really have to think about where the compute even comes from, but we do have a enterprise version that people have used for quite some time, where you can bring your own compute, connect it to AWS, GCP, Azure, and then run this platform that you're going to see on top of that. And I just want to mention that serverless is in beta. So if you do experience any bugs, please let me know. Also at the core for the workflow engine, kind of piece. It's built on top of Flyte, which you might have heard of, Flyte. It's one of the most popular open source orchestration tools that we're also one of the core maintainers of as well. So if you want to, you can go check out the open source to do a lot of what we're going to see today as well. And then just to kind of reiterate, we saw what those tasks kind of look like. Each task is containerized. The inputs and outputs are strongly typed. And then every time we run this workflow, it's going to have like a version of a snapshot of the whole workflow. We'll see this in action, but has declarative infrastructure. So actually, if I go back to a task here, you'll see this is exactly what it looks like to request specific resources, where I'm saying I want 2 CPUs here, 2 gigabytes of memory. And then every time it's run as versioned, we have caching to enable caching. Again, we'll see this in action, but we actually just add in this cache equal true parameter to this decorator. So when we build a task, we're going to add a task decorator, and then type safety. And then it's extremely flexible. It'll probably already work with most of your Python libraries in the ML world, but there's also a pretty powerful plugin ecosystem. And then it's scalable, so it's built on top of Kubernetes, and then also as a user interface and Python API, but we'll see both in action here. So again, a couple more things. So we're going to use the Bert model, like I mentioned before. If you want to read more about it, you can check out the paper. Like I mentioned, it's one of the more popular, or was it one of the first popular transformers models. And then saving and versioning model. So everything kind of is versioned here in Union, like we talked about. But as an optional piece, I will also show how to connect to Hugging Face, which is a pretty common thing to do as part of a workflow. You might want to move data out of this to some other area for deployment or versioning, like if you wanted a separate like model hub to store versions. And with that, let's go ahead and get to the hands-on part. So I'm going to share this link in the chat. Again, everything's in the description as well. That's going to be the notebook that we're going to run from. And again, if you haven't signed up already, hit the sign up link here. Should say join. It might take like 3 to 5 minutes for you to get onboarded. And if you don't get onboarded, let me know. So I think there's some policies in place. Like if you have a super new GitHub account, you might not get onboarded immediately. Let me know and I can see if I can push you through. So I'm going to give everyone a couple minutes to do that. 1, sign up. 2, open up that GitHub link, which will take you to this. And then you're going to want to hit this open in Colab. This is going to be the environment we're going to run in. I will share this direct link to that in the chat as well. And then what I like to do, you don't have to actually do this. It should run without doing it. I like to save a copy and drive. That way, if I edit any variables or make any notes or anything like that in here, it's mine and I can come back to that version. Don't worry about breaking anything. You can always come back to this original one if you want to like start it on GitHub or bookmark the Colab version. So I'm going to hit save a copy and drive. And I'll zoom in a little bit for you. Hopefully that's going to be good. Again, there's links up here. So back to the original version in GitHub. Sign up here. Once you've signed up and got onboarded, you should be able to click this second link, which should take you to a dashboard that looks something like this. You won't have all these runs because it'll be a new thing. But once you're in this, you should be good to go. And we should be able to run the rest of the workshop. And then optionally, you can sign up for Hugging Face. And again, while everyone is kind of doing the other sign up stuff, I'll quickly maybe go through what to do on Hugging Face as well. And I can come back to this if you want later. So again, this is an optional piece where we're going to train a model. We're going to use the model in Union today as well. But I did want to show how to like move it over to something like Hugging Face if you wanted. Once you have an account here, which you should be able to sign up with Google, it should be very quick. You can go to access tokens and then create a new token. I'll just say workshop example, but you could call this anything you want. And then you just want to give it write access. So click this. It'll also check the read one. This allows us to write to Model Hub, which you can kind of think as the Model Hub is kind of a GitHub repo specific for like machine learning models. Hit create token, and then you'll get this key, and then you can save this key for later in the workshop. But again, it's also optional, so don't worry about it if you don't want to do that piece. All right. So once you have this notebook open, I should have probably ran this already and then gone through the Hugging Face piece. So I'm going to run this first code cell. You can run code cells by clicking this play button or hitting Shift Enter when it's highlighted. So you'll probably see me hitting Shift Enter a lot. And if you haven't used Google Colab before, it's Google's way of hosting a Jupyter notebook, which is if you haven't used a Jupyter notebook, it's kind of an IDE where you can write code and text and documentation, see visualizations all in one place. It's a very popular tool for data scientists and machine learning engineers. And it also, Colab comes pre-installed with a whole bunch of libraries already, like the latest version of PyTorch and TensorFlow and scikit-learn. We're just going to install one more here today, which is the Union library, which is going to allow us to write the workflows that we saw earlier. Again, we'll be building a workflow that looks like this. All right, that's installed for me. And then once that's installed, run this next code cell, which will authenticate your Union account to this environment. Click this link that gets generated, and then just hit next here. Don't change the text there at all. And then it should just take less than a minute, and we should be authenticated here. And then we'll be able to write code here, kick it off. We can run it locally as well, but we'll also be able to kick it off and run it on Union servers. And also, don't worry about these like warning messages. I think this is a new version of TensorFlow or something that was added to the notebook that we're not actually using. I think everything should actually run fine here. Just you'll get this warning message. Don't worry about that for today. I'm going to look and see if I can get that to go away later, but everything should work fine. Let me know in the chat if you were able to create an account and maybe get this far so far. That'd be a great little checkpoint for me to see if people are able to follow along. And I'm going to get a drink of water while people are hopefully typing in the chat. No one has said anything yet, but maybe that also means there hasn't been any issues. So I will keep going, but let me know if you run into an issue. All right. So, oh yeah, and the main reason why we didn't need to install other libraries, even though a lot are already in Colab, is we're going to run our model and stuff today in the Union compute with GPUs that are available because we're running or training a large language model. So doing it locally would take a bit of time. Rich said he's in. Took a while for account to get created. Yep. Like I said, I think it takes like 5 minutes or something to onboard you. So again, if no one gets that onboarding after 5 minutes, let me know. I'm going to keep going, but again, let me know where to go back to or anything like that. So we're going to build one of the simplest workflows possible, just to kind of show you a couple of the conventions for using Union. So we're importing FlyteKit, or from FlyteKit, we're importing tasks and workflows. Again, a task is what is going to make up each one of these nodes. So this is our whole workflow. Each task is going to be one of these, like download data set, train a model. And then the workflow, which we'll see here in a second, the workflow decorator is going to allow us to define how data flows between all these tasks and the order to run those tasks. And we could build multiple workflows. You could add workflows and workflows. For today, we're going to be building a single workflow with several different tasks like we saw. But here is, we're just going to create a simple task here. It's just a Python function. It takes in a name that is annotated as a string, and then it's going to output a string. So our function is hello world, very common first start in Python or using a new tool. And it's just going to output hello, the name that we pass in. And then our workflow here, we're not tying multiple tasks together yet. We're just going to return our single task here, and we're going to take in a name when we run the workflow. So I'm going to run this code cell. And I'm just going to quickly note, so up top of both of the code cells where we're going to create these workflows, you'll see this write file and then like a Python file name. This is actually a magic function of Jupyter where we can say this, and then it'll actually generate a .py file with the code below. So if you hit this little folder icon, you'll actually see we have this simple workflow.py file now that is generated from the code cell. I'm not part of how Union actually works here. I'm just using this for the kind of workshop because it makes it easier. And then also, maybe teasing a little bit about something coming soon is we will have an easier way to do this from Jupyter Notebooks where you won't actually have to generate this .py file. You'll be able to register workflows and stuff directly in the notebook, which will be cool. And then, so we created that to run that. First, I'm going to run this locally. So I'm going to hit Union or type Union run, and then the name of that Python file. And then main here is the name of the workflow. And then I know it's required to take in a name that's a string. So we'll just pass in Flyte at first. Maybe this should say Union. Again, you could change this, hit run, and it returned locally the string hello Union. Now let's run this on a remote compute cluster. So I'm going to hit Union run and then just add in this remote flag after run. Same thing we did above. Now it's going to kick off this job or this whole workflow in Union, which again for serverless, it has just a compute cluster that it's calling here. Again, ignore these warning messages. I'll have to look at that. There's something that just happened, started happening today. Like I was saying, Colab comes pre-installed with a whole bunch of libraries, and I think it's something with that. But again, we're not actually running most of our stuff here today, so it should be fine. And mine's actually already done running here. You see it generated this link. It said, hey, we're running this remotely. Go look at this link. And I'll actually run this again to try to get it before it's done running. Click this link, and then you'll see it says it's in progress. You can go to this graph view if you want to kind of see what your whole workflow looks like. This is what I showed you before. But there's also this node view that has a kind of a whole list of everything. And then we can click on this task, which again, this is a super simple one here. We can see there's some things we can investigate here, like inputs. We can see the input was a string Flyte. Outputs was this hello Flyte. And then there's some other metadata around the tasks. If I want to rerun the whole workflow or just a single task, I can do that right from the UI. So let's actually rerun this whole workflow. And I can give it a new string just right here in the UI. Again, you could also do this from an API. So I'll say workshop attendees, something I said before. Hello, workshop attendees. And then so I'm going to launch this and I'll relaunch. You'll also see that this version changed. There's like a hash showing the version. And it's also logged here that it's related to this other one. So this is like the original one. Like we mentioned, everything here is version. So you can actually come back, get all the artifacts generated from each task or workflow here. In this case, we're just doing something simple with text, but you can imagine how powerful this could be in a machine learning pipeline, and relaunching workflows like this just from the UI or from the Python API makes it really easy to do experimentation, where if you want to adjust hyperparameters, change out model types, anything you can think of that you want to build into your pipeline, you can have that become part of this launch form and then just adjust those variables as needed. Or even, someone else in your team could take this in UI and rerun it with different parameters and see what the results are. So you got this far. Hopefully everything else will run very smoothly now. We built our super, super simple pipeline here, our workflow. Again, below, we're going to build that much more complex one. If you ever have questions about like a workflow, you can call help on it. So in this case, it says, names, the name variable is required. And there's a lot more stuff you can do with workflows, like registering them into different project domains, scheduling them, etc. Actually, for the different project domains, as you're navigating the Union UI, let me just show you something real quick. I'll hit this little Union icon. That's going to bring me to this like home page. I have 3 folders. I think you'll have 2 by default. You should have Flight, Snacks, and Systems. If you wanted to, you could create a new folder. So these are called projects. So you can organize different workflows between projects as well as different domains. Like in a project, you could have development, staging, and production. We're going to be running stuff in the default environment, which is called Flight Snacks. That's kind of like our little demo folder that's already there for you. But just wanted to note that you can create other folders and kind of store workflows kind of in an organized fashion. All right, so is everyone ready to run the other part? For the person who said they were still waiting to get onboarded, were you able to get onboarded? And if not, let me know, And if you can share your GitHub handle, I can try to take a look. So again, the optional part is you could create a secret with your Hugging Face token. You could run this. Again, don't worry if you don't have your Hugging Face token. This is just kind of optional. So I could get my Hugging Face token here. And then this is kind of hard to see, but it's a text box. I can just paste that in, hit enter. For me, I already have an existing token, so it's going to throw an error. And I can actually pull union get secret, and this will tell me my tokens that already exist. So it manages all your secrets in here as well, which is very nice. And you can do things like run OpenAI calls or anything you want with tokens, like using weights and biases or YLabs for ML monitoring. You can easily build an integration and just have those tokens managed in Union. If you ever want to delete a token, just call it delete secret and then pass in that token name. All right, so we can go back if you want to get your token too. What I want to do though for this next part is there's a lot of code here and I want to walk through it. But I also want everything to be kind of trained in a timely manner. So what we can do is run this code cell. And again, it's going to write it to a file called bertfinetune.py. And then scroll down. So these are all of our tasks that we're going to build. And I'll walk through this here shortly. And then underneath this, you will see that there's this union command to run. First, I want to note, so we have this save model task as part of the workflow that's optional. It's uncommented, or it's commented out right now. So if you run this as is, it won't save the model to Hugging Face, even if you created that token. So if you want, you can uncomment this out and have that extra step of moving a model out of Union into Hugging Face. And then when you do that, you want to provide your Hugging Face name and then some sort of repo name here. But if you don't have that, don't worry. You can just run this code cell as is, and it'll run the workflow without the saving model. So I did have mine. I'm going to go ahead and say Sage Codes, and I'll say LM repo. Again, don't worry about this. Actually, even if you want to do the Hugging Face part, I would say don't worry about this for now because you can run this first workflow, and it'll build a container and everything for you. And then you can come back and run it again if you want. So go ahead and run this, and then I'm going to walk through the code because it can take a while to, one, you're going to have to build a container, and then it also takes a while to train the model. So I'm going to hit run here, and then we're doing like we saw above, but we're calling this Bert fine tune workflow. Again, don't worry about those warnings. I have to see what's causing that, what update I think in Google Colab happened. And then so for me, it says the image that I want to run in is found. So it's skipping building. For you, it should say image not found, building now. So it'll take a few extra minutes for you to build that image. And I'll show you how it's finding that and the specifications for that image here in a second. So I'll click this and I can see that my workflow is already running. One fun thing to see here too is that download dataset and download model are already done for me. The reason why is because I had caching in my pipeline. So I'm rerunning this workflow. It was already ran before. And it's just saying, oh, cool. The dataset already exists. The model already exists. Let's not download this again. Let's just get straight to training. So it saves time on my end here as well. And yours will also take a little bit longer because it has to download the model and dataset. So let's go back and look at the code that is making all this happen. I'll go up to the top here. So first, I'll just kind of talk about the imports probably when we use them later. The first interesting or cool thing here is we're using something called image spec that's in Union, where we can specify variables about our environment, and then we'll build a container on it. So you don't have to mess around with like Docker or Docker files. You can do it all in Python in your code here. In my case here, I'm just specifying specific Python packages that we want to install. But you can add more packages with like apt-get in your environment, CUDA versions. You can get really specific with it, just like you can in Docker, but it's right here in your Python code, which is very nice. Then next, we're going to download our data set. And also, just I want to mention, so this is all in one code cell. It kind of makes it easier for me to show it during a workshop. But you can break up this into different Python modules. So like you could have a data file for all of your data tasks. You could have, and then import them into a workflow file. And that's kind of what I did here. So this is like a data.py file, have all my data tasks, and then I would import them into like a workflow. And it just allows you to write much cleaner code than having it all in one code cell here. So I would recommend that if you're doing it in production, but just want to kind of show it all in one place here. So now we're going to get to our first task, which is download dataset. And we're using the task decorator like we saw before, but we can add a lot of parameters to it. And there's like a lot of kind of heavy lifting that these parameters do. And if you've ever tried to implement like a Kubernetes pipeline or enable things like caching and stuff like that in pipelines, you might be like, oh, like this kind of feels like magic. We have this task decorator, and then so much, it's doing so much for me just based on parameters I pass in. So first we're saying the container image we want this specific task to run in. So again, you could use different images per task. We're going to use just one image for all the tasks today. And that's the image that is here above. That again is being built in Union for you now. And then when you call it, it'll look for that, see if it exists, and then pull it into the task. We're also enabling caching on that first task, so that every time we run the workflow, by default, it's not just going to download the data set again, but you can also give it a cache version. So if you want to update a new data set to a specific version, you can do that, or like go back to previous versions. And then we're going to request the specific resources that we want in our task, just like we kind of saw on the slides earlier. If you're here for that, we're requesting only 2 CPUs and 2 gigabytes of memory for this task of downloading the data. When we get to something like training the model and evaluating the model, we're going to want to up these requests quite a bit and use a GPU. So we'll see how to do that here shortly. So we have our Python function, which again, right, you're writing these tasks, you're really just writing Python functions almost like you normally would. One caveat is, again, everything has to be strongly typed. And then you'll actually see this special type here called Flyte directory. There's Flyte directory and Flyte file. And has anyone kind of developed in containers before? So it can be a little bit of a different mindset shift sometimes. So here we have our download data set. When this is running, it spins up compute in a container, it runs stuff, and then when it's done, it spins it down. So it doesn't really exist anymore. If you want data to persist that you did, like if you downloaded data in this case and you want to persist outside of this container, you have to like move that to a different blob storage or somewhere that you can get it again. And you can just use something called Flyte directory or Flyte file in Union. And what that's going to do is save that data to a blob storage, and then you can reference it in other tasks or anywhere else, really. So this is just like spun up the compute, downloaded the data set, and then we're basically saving this cache directory for where our data set's going to be saved as a Flyte directory. So every time we want to pull in this data set in another task, then it will be already saved and we don't have to download it again. And then we'll get to download model, the next task. Very similar above, we have caching, same container image, same requests even here, CPUs and memory. And then again, we're even downloading a data set and saving it to a Flyte directory so we can reference it in other tasks. We're getting, so just to, I guess, mention here, I didn't go through this. So we're calling load dataset IMDb. That's kind of the dataset from Hugging Face that we're going to use. It's a whole bunch of IMDb reviews of positive and negative reviews for movies. So very unstructured text, and we're going to train a classification model for that. And then so when we load dataset, it's going to look at this dataset cache directory, and that's what we saved as the Flyte file. So we downloaded the model as well. And when we load in that model, it also has a cache directory option, and we're saving that model cache file in storage as well. So then we can pull it in. Then we have this next task, which is visualize data. Same container, same resources. We're doing something new here. We're enabling a deck. So we're saying enable deck equal true. And that is this task here. And you'll see that this has a button called Flyte deck. The other ones by default do not. You can hit Flyte deck here. And then this contains, we're going to show how to build this. This is like our data analysis that we do on our data set and then kind of log it per workflow or task. So we can go get more data about what was used to train our model. But it also has a few other tabs by default, like timeline, source code. So again, all this is kind of snapshotted and versioned anyway. Flyte deck allows you to kind of view this per task. And when you create your own things like this data set analysis, you can use Markdown or HTML and really embed anything you want here, including cool things like Plotly and stuff like that. If you want a 3D thing, you can have that logged per task here, which is pretty nice. It also has the dependencies, the input, which is this is where our data file was, and then output. We weren't actually outputting anything here, but it's all kind of logged here, and you can see it all versioned in this Flyte deck per task and per workflow, which is pretty neat. So we're going to show how to build this deck here, which again, we're going to use HTML, generate some charts, and then just kind of log out samples of our positive and negative reviews. So we're loading in our data again from that cache directory. We're getting the train and test data frame by splitting on train and test. And then we're just getting things like the first positive and first negative review, both from training and testing. And then we're just creating matplot figures here, which are those bar graphs you saw. We're going to convert those images to base 64 so they can be embedded directly into the HTML. And then here's our little HTML report. So again, you could write HTML. You could also do Markdown. And then you can just embed like those Python variables directly in here, which is really neat. It makes writing these reports pretty easy and dynamic. Then we're going to add the HTML report to the deck by calling deck.append. And then we're also going to insert it at the index of 0. Otherwise, it's just at, I think it's at the last one by default. But you can move around the order of where you want these decks to kind of be displayed at. So you could write multiple decks as well, not just one. And then we have our train model task. So one of the big differences here in our task decorator is we're requesting more compute. We requested more memory and 1 GPU. And here I requested 4 CPUs, but actually might be too many CPUs since we're using a GPU. In this case, they don't cost us a lot, but in general, it's good practice to observe the resources you allocated per task and then the resources you're actually using on those tasks. And then you can actually bring those resources down. So maybe originally I was doing it on CPUs or something and I had 20 CPUs and then I was paying for that each time, even though we were just using one, that would be costing a lot more per run of this task. And I could look at that and bring it down. And so you can actually look at that. Let me see if my model's done here. It is. You can actually look at that with this view utilization button. Let's see what it says. So again, you can see I allocated, see, this is actually memory. So I allocated more memory than I needed as well, actually quite a bit more. But I allocated 4 CPUs. We only used 1 CPU because we were using the GPU for most of the computation here. So then I could go in and adjust this down pretty easily to 1 CPU or whatever, and then even the memories. I might not actually do this to run this right now, but I can bring this down into like what my tasks actually need versus what I set them with, because it's pretty common. You might have even done this before. I know I have, where I just set some resources and I said, oh, it works, and then I didn't go back and tune it down, and maybe it was like way overkill, which again can be really pricey depending on what you're doing. So we have our train model function or task. It's going to take in the model name. So originally I was making this where you could like change different models out in the launch form. It's going to take in the Flyte directories for the data cache and the model cache. By default, it's going to train for 3 cycles or 3 epochs on the data, which we're going to do here for the workshop. You saw it didn't take too long, but if you're looking for better results, you probably want to up this to a much higher level, and probably will learn better from the data that we pass through. And then it's going to return a Bert for sequence classification model. We're importing some of the stuff from the Transformers Hugging Face library, like tokenizers and trainer. We're getting the path for our working directory using this current context method in Union. And then we're getting our training directory. We're loading our data set again with that cache file. And then we're using auto tokenizer. So it's going to bring in the model and the data and figure out which tokenizer to use. If you're not familiar with tokenization, LLMs, it's kind of the way of chunking up how it reads in text to train. So like you could think of it like usually breaking on or you could think of it like breaking on a sentence, like maybe in the space between words, but that's not really how tokenization usually works. It might break up parts of words. It could be per letter. There's a whole interesting thing around tokenization and how it affects your LM learning. Like I think Andrew Kapathi did a cool talk on how one of the reasons why ELMs originally wasn't good for coding, I think, was how they were tokenized. So it can affect stuff, but go definitely play around more or go learn more about tokenization, like what types you want to bring in. Then we're passing in the model name. So it's going to get a pre-trained model from Hugging Face. So again, I think by default, we're using like Bert uncased, number of labels. So we just have positive and negative for our class today, a classification model today. But you know, if you had 3, you want to change this to 3. And then this is pretty common. You'll see this with like Hugging Face models. You have 2 dictionaries. One is ID to label and one is label to ID. So it's just saying 0 is negative and negative is equal to 0. And then we're reading in the model from that cache directory. We have our tokenizer function. Again, I'm going to go through a high level on this, and we could come back through like after the workshop. But I want to make sure that we get to the end of the code here, and you will have trained a model. So we get the tokenizer. Also noting, so we're just kind of splitting the data set here, we're getting a sample of the data set. So again, we wanted to make this so it could run during the workshop very easily versus I think it's 25,000 samples from train and test. So 50,000 overall. So just for this kind of workshop, we're reading in the first 500. Actually, it's shuffled. So it's just 500 samples. And then we're reading in 100 from the test data set. Then we are computing the accuracy. We're going to create some training arguments, which is the output train directory. It's going to evaluate every single epoch, and then it's going to train for the 3 epochs by default. But again, you can pass in that parameter that we're going to call train, or we're going to initialize the trainer, which is a big abstraction just of how to train models in Hugging Face. We're going to give it the model, the training arguments that we had created, pass in the 2 data sets that we just talked about, and then what kind of metrics we want to compute. Then we're just going to call .train on it, and then it's going to run and return the model. And then we have our evaluate model. We enable deck again. We also need a GPU for this one because we're actually going to use that model. Again, maybe it's too much memory here. We might want to tune this down. And we're taking in the model that we just trained, the 2 Flyte directories for the model cache and the dataset cache. And then we're loading in part of that data set again. One thing I will note is they didn't have a separate train, test, and valuation. So I am taking a random sample from the test data again, not necessarily the best practice. And I should have probably created just another split for validation. So there could be some leakage between the data sets. So again, you would want to update this to have a separate validation data set. Using our tokenize function again, and then this is the test one. It's shuffling. We're getting 200 samples, so again, it's probably not that much overlap, but there is a chance of that happening. And then we're going to get accuracy, F1 score, precision, and recall, all classic classification metrics that you'd use to evaluate a classification algorithm. And then we're going to load in 16 samples per batch. And we're just initializing the trainer again, but we're calling it .evaluate, which is instead of updating the weights, now it's taking the model and getting prediction results from it. So then we'll return those eval results, and then we have our save model task, which again is optional here, but we're going to take in that model. We're going to take in the name for a repo. We're going to basically just save that model. If we save it, we get 2 files. We get safe tensors and a config.json, and we want to upload both of those to a Hugging Face hub. So we're just going to validate that those are there first, and then we're going to get an environment token if it exists. Otherwise, then we're going to go ahead and get the token that is in Union, and then we're going to initialize that Hugging Face API. And then for each of those files, we're going to loop through and then just call this API.upload. And you give this a file name or object. So this is like where it lives. And then the file name, you want it to be in the repo name. Again, for us, If it doesn't exist, it's going to create it. And if it already exists, it's going to overwrite it because we have this exist OK equal to true. And then we're going to add a commit message. You can have this be anything you want. It's just going to say upload file name. A repo type is none, but there's different types of repos you can have in Hugging Face, like a dataset repo or a regular one, which we're using a regular one where you can upload just any file to. A dataset has some other special stuff going on. They're going to pass in that Hugging Face token that we got. And because I didn't mention it, we get that one. If you were here when we ran that code cell of creating our secrets, we pass in that specific secret here in the task as well. So most of the stuff like that we're doing with Union is done here in the task or defined in the task. So that's called declarative infrastructure. So you're kind of saying like what resources you want and anything special to happen here, you kind of say in this task decorator. Then we have our predict sentiment. So sometimes when I'm training a model, I like to have a separate kind of task available where I can just pass in text that I know is going to be maybe completely different from the evaluation data set or from the training data set and see how it performs. So I went ahead and added that task just as part of our pipeline today. Again, if you're building workflows in production, you might want to break this up depending on your team. Like you might have parts of the data piece be part of data engineering. Training and evaluation could be separate workflow. And then you could have like some other separate prediction and kind of shipping workflow potentially. But today, they're all kind of all in one workflow here. And I wanted to be able to call this in my pipeline. You can also call tasks once they're kind of registered outside of workflows too. So we'll see this here, how we can actually use this task as a form of a deployed model for batch inference. So here we have our predict sentiment function. We're just kind of importing the models that we already trained, and then we're going to return the prediction on it. And then those are all of our tasks. Now we're going to put them together in our workflow here. So again, we're expecting a model name, which by default is going to be the Bert based on case, a model string, a test text. So this is going to be passed into this predict sentiment. So you could add this again as an extra test and see how your model behaves. The number of epochs by default is going to be 3. And then this is just all of our tasks above, kind of listed as functions here. So we have that download dataset, download model. They're being passed to variables here. And the way that we use these variables in other tasks here helps us define what our full workflow looks like. So this whole flow of data, that's what the workflow piece is doing here. All right, so that was a lot to go through. But if you ran this, you should have a workflow that looks like this. You might not have the save model if you didn't do that as the optional step. But now you can go to download data. Again, you could click around it like we have this input, output, etc. The more interesting task to look at would be this visualization data or visualize the data. And then also we had evaluate model. So let's actually see how our model did on our evaluation data set. I think I forgot to make a cool visualization here and put in the Flyte deck, but we do return the loss, the evaluation accuracy, the F1 score precision, etc. And then those are all logged here. They're also logged in JSON and the output. So you can see that if we had accuracy as our score, it's 80% accurate, and recall is like 86. So we'd say like, this is like at 86% accurate on our test data set. And then this is our predict sentiment task. So this is where we could pass in some random text. And we see that the input text here was, I love this movie. And this is the model it's going to run on. And the output for this was, it's positive. It thinks, I love this movie was very positive, even though that was much shorter than a lot of the unstructured text it was trained on. So let's actually see what is something you'd want to pass in and see how it performs. Maybe something more tricky, a little bit more complex. If you want to, you can rerun just this task now from the UI. So it has this model stored in a blob storage. And then we can actually run predictions on this. And so this is actually kind of a common use case where, again, maybe it wouldn't be part of this whole workflow. You could have a separate workflow with this. But now we have a hosted model that we can run batch predictions on. So it still has to spin up the container. So it's going to take a little bit to give us that prediction back. But this is a common way of hosting models when you don't need like live things like a chatbot getting back to you right away. You might want to process like thousands of documents and get, maybe in this case, like a classification score on them. So let's pass in something a little bit more tricky. This movie had 40 minutes of can't spell. I can't spell either. Minutes of farming wheat. Wheat has an H in there, right? Has anyone watched Rebel Moon Part 2? There was like a lot of wheat farming in it. So this is kind of a weird one because you're like, is this good or bad? It's a lot more ambiguous. Let's hit launch. This is going to relaunch just this single task. So it's going to take, again, a few seconds to spin up here, that whole container, load in that model again, and then perform classification on it. So it'll take a little bit here, just the way we have it set up. And then going back to the notebook, all the stuff that we can do in the UI, we can also do right in the Python API using this Union remote. So that includes anything like, let me see if I have another tab open. Looking at all of our previous executions, getting different versions and names of these, and going in and getting specific tasks, getting specific artifacts. So in this case, like the input was this model that we trained, and we have this train model task. If we want to access where this model is saved, how do we pull that down, or how do we run another task with this specific model? So you can do that all through the Python API as well. We'll import Union remote, and then we're going to look through all of our executions. In my case, I'm going to limit to the last 10. You probably don't even have 10 in there yet, but you might have a whole bunch. So I'm just going to look at the last 10. And then for each of those, I'm going to see, do any of them match this specific name? And so if I went back to my executions, you'll see that here, this is the workflow name. And that's basically what I'm querying for. And then I'm going to get a list of those executions. Oops, I didn't run that. I get a list of those executions. And then I want to basically get the last one with that name on it, which gives me this version number, which, again, if you wanted to double check, you can come back and see. That's the latest one that I ran. Exit out of that. All right, and then I can get some details around. Sorry, now I'm going to fetch the execution with that ID number. Then I get whole details around the execution, and then I can get all the outputs that were logged for that. So in this case, it's like the evaluation score, everything we looked at in the UI, but now I can just pull it down from the Python API. And then I want to get the outputs of the fine-tune LLM and the model cache, where the architecture is stored. So that's stored at output 0 and output 1. And then I'm just going to print those out. You can see these are URIs where those live. And then I'm also going to get a specific task. So I'm going to get that predict sentiment one that we just ran. And then now I have my predict task. You can see some stuff around it, like the type of variables it takes in and arguments. We're going to now call this and pass in these inputs. We're going to say, why does this movie have 40 minutes of farming wheat? And then we're going to get the model cache. And then the model is a Flyte file, which is where the URI stored it. And then we're going to execute that model, pass in those inputs. And if I run this, now we have this little link. And we can see that this is executing the model. Once it's done executing, I can resync and then pull in the data that it generates. I can also have a wait equal true argument in there. And this way, it won't generate a link here. It'll just run until it's done and then pass an artifact or variable into the Python here, which we'll see how to do that down below as well. While that's running, we can see our other one is done. And the outputs was, it thinks it was positive. It thinks farming wheat is a positive thing here. But yeah, a little bit more ambiguous thing that's kind of hard to predict on. But experiment too, if you want to experiment with this model, passing in more complex things, or go to like Rotten Tomatoes and get a more recent review and pass it in and see, what it thinks it would be. It would actually be interesting to train it to predict like the actual like Rotten Tomato scores versus just good or bad. So our other one is done too. We can pull in the execution and pull in the outputs here. So it, in this case, thought it was a negative. I'm not sure if I changed the text between them. I think I might have more than I thought. Someone said they tried this thing is quite cumbersome, but at least it works. Nice. And what was the result? Also, so in this case, we kind of access those variables by um, basically functions that were already run. That's kind of how these tasks behave by default. There is a way, kind of easier way or more manageable way to do this with something called artifacts built into Union. And I'm going to probably redo or remake some of this workshop over the holidays using like artifacts. So where instead of basically querying um, a task version and getting that, we can actually specifically say, hey, save this as an artifact, and then I can just reference it from different workflows and tasks, and it makes it a little bit easier. You also get other features like lineage. So you won't have anything in the artifact store right now, but you can see like I have this k-nearest neighbor model, and I can see like different workflows where it was generated, and then when it's used, you can see where it's used as well. So I just want to note there is a way or features that make this even easier. And then we went through a lot here. I'm going to show one more quick thing, but basically this is mostly what I had for the workshop. If you follow along, like you went through, you fine-tuned a large language model, and then with like state-of-the-art features, by the way, not just any pipeline here. Like you have a full pipeline that downloaded a model and cached it. You trained a model, you visualize the data and have like a really nice visualization that you can come back to for this version of the workflow. So again, maybe you update the data later, you want to train on there, and then you want some information again about that data set. You could go look and see how it changed. We evaluated the model, and you predicted sentiment kind of in a hosted model for batch inference here. So we actually did a lot in our 1 hour. I know it can seem like quite a bit too, depending on your level of what you've done before. So one, what do people think? Was it interesting? Was this cool? Do you feel like you could totally do MLOps now? So this last piece, again, is kind of optional here. And I know Gradio updated recently, so I think there's a little quirkiness I need to maybe mess around with or try to fix from the new Gradio version. But here, Gradio is kind of a way of building a interface, usually for like data science and ML applications. We're going to do all the stuff we did above, but wrap it in a Gradio app, where if I run this, we'll see if it runs. Like I was saying, this can be a little tricky sometimes. While that's going, down at the bottom here too, there's more resources. So again, this was just fine tuning a large language model. If you want to look at how to do RAG in kind of a similar system, like versioning, the reproducibility piece, this one actually uses artifacts, I believe, too. So you generate a vector database, have that stored. You can then just rehydrate a vector database with that artifact in any other workflow. And those artifacts are really important because, like I had mentioned, often you have different teams working in different parts of the pipeline. Like you might have a data team, an ML engineering team, and you want to be able to store that data and pass it very easily between teams and see the versioning and see the lineage. Artifacts kind of enable all that. All right, so we have this little interface now. So we can pass in, I'll say I hated this movie. Again, you could type in anything you want, hit submit. Now, what I think the weird little thing right now is I hit submit on this, and Gradio used to have a little loading icon saying like, hey, it's working. And for some reason, they turned it off by default in the new one, and I did not enable it here. But if I went back and I look at my executions, I can actually see that one was kicked off here. And now it's getting a prediction back. And then it'll take a minute and populate it here. So this is kind of a weird little Gradio thing that happened with Gradio 5. I need to enable the loading icon. I think by default, they took it off for some reason. Someone said, thanks, very cool demo. Awesome. I'm glad you liked it. Rich said, nice job, Sage. Thank you, Rich. Yeah, we should sync up sometime again, too. I want to build out some examples. Like I'll be building out more end-to-end examples, too. So if people are interested in maybe coming to a longer workshop, but also I'll have them in like a blog format as well and code. if you want to see more end to end with like other tools in the pipeline, let me know if that's interesting to you, because that's something I think would be interesting and that I kind of want to build out more of. So showing how to do, a full pipeline like this, but then also have like the ML monitoring piece. And so like when your model's in production like this, you could look at how people interact with that model, how your model's behaving over time. And then if, people are interacting in weird ways, you can capture that. You can set up guardrails. I think that would be really interesting. Maybe more too in the experiment management space. So even though everything's versioned here, sometimes you want to pass it out to something like weights and biases or ML flow and have different visualizations around it. Also for different types of models, like I guess actually for LLMs as well, you might want to have like data annotation. I had mentioned I've done a lot of computer vision before, so like working with a data annotation tool is interesting. And like if you've never done that before and you want to train a computer vision model, you'll learn a lot around the data that you're working with. It's pretty fun. We can see this actually did return back this little thing. It says sentiment negative. I'll do another one again. Oh, hey, there it is. This is what it used to do. I don't know why default the first time I ran it, it wasn't there. This makes more sense because it shows you like, hey, something is happening. Here's the time between. I get this called back. And if you want, you can actually, I won't show this today, but you could take this code and actually go deploy this basically in a Hugging Face space. So if you actually wanted a deployed app, you could take this, deploy it in a Hugging Face space. You just need to get a Union API key, which you can get by calling Union create app Gradio app. It'll generate a API key. This is really just any name you want. Also, I'll mention too, since people are still here, there's A100s in serverless. So if you want to train a much more complex model, like a llama version, you can check out using the A100. By default, because we just said GPU is equal to 1 in our task today, I think by default that's an L4 or a T4. But you can specify specific accelerator types. So here, it's I want GPU 1. I want that accelerator to be an NVIDIA Tesla A100. And I think in serverless, there's L4s, T4s, and A100s right now. And this one got back positive. Let's stop on this. Cool. Again, that was kind of the workshop workshop material I had planned for you. Stick around a little bit more if you have questions, but there's also just a lot more resources on Union.ai. Go check it out. And there's a lot on the Flyte channel as well. And like there's an example, or sorry, a recent talk that LinkedIn did. So LinkedIn switched all of their large language model workflows over to Flyte. And you can check out kind of what their architecture looks like and their learnings from that, which I think is pretty interesting in this presentation they did that I shared in the chat. Someone said, is AWS on, or sorry, is Union on running on AWS? So Union, the bring your own compute, can run on AWS, GCP, or Azure. And let me just try to find the best place. Like if you go to docs, you'll see there's 2 versions, bring your own compute and serverless. So serverless is what we use today, kind of a beta version where you don't like need to know per se where the compute's running. We just have those resources available for you from different clouds. And then bring your own compute is what most enterprises actually use. And that's where you specify, like, this is my AWS cluster, or this is my GCP cluster, and we're running our compute in there. Oh, someone said, thank you. We'll rewatch it again and complete the project. Awesome. Yeah. If I think I might have missed, sorry, if you said that you still were not onboarded, I will go look. If you can, connect with me on LinkedIn or somewhere and let me know what your GitHub username is. Let me bring up my LinkedIn, or in the Slack channel. If you join the Slack and maybe mention it in one of those channels, or DM me there. I can take a look at it. So sorry if you weren't able to follow along. But those are feel free to ask me questions as well. But also the Slack channel is a good place to ask questions, but also introduce yourself. There's a more permanent introduction channel there, so it's fun to kind of see who is watching. With that, I still see quite a few people here, but I'm gonna wrap up the workshop. I gotta go do some other stuff. Timothy said, as usual, very nice. Timothy, always a pleasure. Hopefully I will talk to you more soon at some other event, whether in person or online. I don't know if you saw, but the December book club is on building large language models from scratch, which I know might be of interest to you. Actually, I can pull up that link too. Yep, I shared my LinkedIn in the chat if you want to connect. Again, I'll stick around for one more minute if there's other questions. I will also pull up this link if people are interested. This is the book club for December, which is the building large language models from scratch. Actually, the author said that he'll try to stop by as well, which is always really fun when they do that. All right, with that, I'm going to wrap up the stream. Thank you so much, everyone. I will hopefully talk to some of you later. But let me know, again, if you have questions in Slack or on LinkedIn. And I'll see you all next time.